This is the lecture video number 7 for section 6.1. Here we're going to do a couple examples. Under the instruction, write each trigonometry expression as an algebraic expression of u. So the first one we're going to be working on is cotangent of secant inverse of u. So u is going to be some number. We're not sure exactly. So because of that property, secant inverse of u, which is equal to angle theta, I cannot really find theta. So I have to use the triangle method to figure out the cotangent of secant inverse of u. So theta equal to secant inverse of u. From the definition of the inverse function, I have secant of theta equals to u. I'm not really I do not like to use secant, so I'm going to rewrite secant theta as cosine of theta equal to 1 over u. So from this one, I know when I have a right triangle and then one of the angle is theta, then cosine theta equal to 1 over u tells me I have a 1 for one side and u as the hypotenuse. Then my side x, which is the one I'm going to looking at, is going to equals to square root of u squared minus 1. Okay, so I'm going to find the cotangent of secant inverse of u, which is the same as cotangent of theta. Cotangent is 1 over tangent of theta. Tangent of theta for this picture is going to be x over 1 comes to 1 over x, where x is equals to square root of u squared minus 1. So rationalize the denominator. I need to multiply by square root of u minus 1 on both numerator and the denominator. So I end up with square root of u minus 1 over u squared minus 1. And that is the answer for the first one. The second one we have is sine of 2 times cosine inverse of u, where this one is slightly different than the previous one. We have 2 times cosine inverse of u. So we are not going to thinking about we have you can think about we have 3 layers. The first one is cosine inverse of u. That will return me a theta. And then I have 2 theta. And then try to find sine of 2 theta. So that means here I need to after I have the theta, I need to using the double angle formula for sine. Okay, so combining those, my first step is going to be theta equals to cosine inverse of u. That tells me cosine of theta equals to u, or u over 1. Then from the right triangle, one of the angle is theta, then cosine theta equal to u over 1 tells me the hypotenuse is hypotenuse is 1, and then one of the leg is u, and then the other one is x. Then to find x is equal to 1 minus u squared. Then I need to, second step, I need to find sine of 2 cosine inverse of u, which is the same as sine of 2 theta. The double angle formula for the sine is 2 times sine of theta times cosine of theta. So that means I need to know what is sine of theta and what is cosine of theta is. I have the cosine of theta, which is u. Then I need to find what is sine of theta. So sine of theta from the right triangle is x over 1, or x, which is equals to square root of 1 minus u squared. So 2 times sine theta times cosine theta will become 2 times square root of 1 minus u squared times u. So end up with 2u square root of 1 minus u squared. The next example we have is tangent of arc cosine of u. So here we have the same thing. as before, arc cosine is inverse function, so this one will return me angle theta. So first, I have theta equals to arc cosine of u. That tells me cosine of theta equals to u. Then I can have the right triangle. Cosine of theta equal to u tells me my hypotenuse equal to 1, and then 1 of the angle equals to u. And then the third leg will becomes to 1 minus u squared. Then my question is tangent of arc cosine of u, which is the same as tangent of theta. A tangent of theta from a right triangle we know is going to be u over x over u. So x is square root of 1 minus u squared over u. Okay, then the last one we have is tangent of arc tangent of u. So this one we have tangent inverse of u is the same meaning, just different way to representing the inverse function. Is means I have from point A and then take the function f to a point B, and then I'm going to take the same return trip, the inverse function, from exactly the place B, go back. So I should return back to A. If f is a one-to-one function, meaning f has its own inverse function. So for D, arc tangent of arc tangent of u, or tangent of tangent inverse of u should equals to u itself.